Okay, everyone. Hello and assalamu alaikum. We are starting. So today we're starting with March 2024, paper 1, variant 2. This is the paper that we want to do today. This is the most recent, this is from the most recent session that we had for A-level math 9709, March 2024. Okay, so this is the paper that we will be doing complete. So this is our session in which we do a complete paper, and then in the next session again we will be doing 2 papers from which we just do the more difficult questions. All right. Now the marking scheme for this paper is not available, so you need to make sure that you keep a lookout for any careless errors. I tend to do quite a few during the course of an exam, so make sure that you are focusing and pointing out if I end up making some plus minus error somewhere, or if I end up copying some value wrong, keep a lookout for that. Okay, let's begin with this. So March 2024, paper 1, variant 2. Let's begin with this. All right. So it says find the exact value of this integral 2 over x squared from 3 to infinity. That these are the limits that we're given. Now, how do we evaluate this? It's a first of all, let's bring x to the power so that it becomes 2x raised to the power minus 2. We need to integrate this with respect to x. Limits are from 3 to infinity. Okay. Now, let's integrate it. It's a power function. How do we integrate power functions? We add 1 to the power, divide by the new power. Let's see what we get from that. 2 remains as it is. We add 1 to the power, it becomes minus 1, minus 2 plus 1, that becomes minus 1, divided by the new power. And then you have to input the limits. Okay, what are the limits? Limits are from 3 to infinity. Now let's simplify our expression first. And then after that, we will be inputting the limits. So we've got minus here, and we've got x power minus 1. We could write this integral as, you could say this is minus 2 over x. All right, and now we can input the limits from 3 to infinity. Now, first of all, in place of x, we've got to input infinity. What does that mean? X has to be something that's extremely large. Okay, let's see what we get from that. We can input infinity as it is inside the expression at this level. It's okay to do it like this, although you will learn later that we don't input infinity in a function directly like this. You will do that in the first course at your university. But for now, it's all right. You can just input the value as it is. Subtract from this minus 2 over 3. Okay, so once you input infinity in place of x and then you input 3 in place of x, this is what you end up getting. Now, what's this? Minus 2 over infinity. That means minus 2 over an extremely large number. What does that become? 2 over an extremely large number. That's going to be something very close to 0. So this whole expression basically goes to 0, right? What are we left with? 0 plus 2 over 3. So the result that we get from this is 2 over 3. All right, that's the final result that we get in this. It says find the exact value, so you should leave it as a fraction. Do not write decimals here. Okay, that's the first question. Let's move on. Question number 2. So the first one was pretty straightforward. As long as you know how to work with infinity, that's all that you've got to do there. Okay. All right. Question number 2. Let's have a look at this. It says the diagram shows part of the curve with the equation y equals k into sine of half x, where k is a positive constant. Now keep that in mind. K is a positive constant, and x is measured in radians. The curve has a minimum point A. This is the minimum point A of the curve. We need to state the coordinates of the point A. Okay, so now what does the function look like? It's k into sine of half x, and there is no way to find the value of k here. So most likely the coordinates have to be in terms of k. Let's think about this. Okay, so the minimum point is A, and it's only a 1 mark question. How can we think about this? Remember what the graph of sine x looks like. So if you have the graph of sine x, how does that look like? It would start from 0, go like this, and this is where it completes one full cycle. If it was sine x function, what would these points be in that case? It would start from 0 on the x-axis, and then when x is pi, it comes back to 0 again, and when x is 2 pi, it comes back to 0 again. And in the middle, this point would be 3 pi over 2, and this point would be pi over 2. That would be for this function sine x. Okay, we're not talking about this function yet. Now, what's happening here? Instead of sine x, there are two things happening. So remember, in sine x, we also have this, that on the vertical axis, we've got 1 here, and we've got -1 here. These are the maximum and minimum points of this curve. Now, what is changing in this function? You're multiplying by k outside. What that means is there's a vertical stretch of scale factor k, or you can say the amplitude of this graph would be k in this case instead of 1. All right, so the amplitude in this case is going to be k. If the amplitude is k, what does that tell us about these points where you have the maximum point and the minimum point? The y values are going to be k and minus k. If the amplitude is k, that means the maximum point is going to be k and the minimum point is going to be minus k. So you can think of it both ways. You can think of k as being the amplitude of the sine function, or you could think of k as the scale factor of this vertical stretch. Either way, the y coordinate of this point k turns out to be minus k. All right, so that's what we have figured out here. Now, what about the x coordinate? What is the transformation that is happening horizontally? Half x. What does that mean? You're dividing by 2 inside the function. In horizontal transformations, things work the other way around. So if you're dividing by 2, that means it's a horizontal stretch of scale factor 2. So the period of the graph that was from 0 to 2 pi earlier, what is that going to become now once the graph gets stretched? The period of the graph is going to become 2 pi into 2, that's 4 pi. So this transformed graph, this is going to complete one full cycle only once you have 4 pi here on the horizontal axis. So this point would have to be 4 pi in this transformed function. All right. So after transformation, 2 pi into 2, the point becomes 4 pi. And now, what about the x coordinate of A? If this is 0 and this is 4 pi, right in the middle, we would have 2 pi. Then what about this point? This is going to be 3 pi. So the x coordinate of this turning point is going to be 3 pi. So it's 3 pi and minus k. These are the coordinates of the point A. And that's what we were looking for. We had to state these coordinates. So there's a vertical stretch of scale factor k, because of which this is what the y coordinate turns out to be. There's a horizontal stretch of scale factor 2, because of which the point 2 pi goes to 4 pi. And the point that was earlier 3 pi over 2, that becomes 3 pi after multiplying by 2. So this point is going to be 3 pi. All right, that's the first part. Let's have a look at the next one. Now it says a sequence of transformations, that means more than one transformation, they're applied to the curve in the following order. Now it says translation of 2 units in the negative x direction. So that means vertically, the graph is going to move 2 units down. Reflection in the y-axis, in the x-axis, sorry. Reflection in the x-axis. That means the line of reflection is x-axis. If the line of reflection is x-axis, is that a vertical transformation or horizontal transformation? That's also a vertical transformation, because x-axis being the line of reflection means if there was a point above the x-axis, that goes below the x-axis. If there was a point below the x-axis, that goes above the x-axis. So it's a vertical reflection. So you've got 2 vertical transformations. First of all, There's a translation of 2 units down, and then there is a reflection in the x-axis. Now, how do we think about this? What was the original curve? What was the original curve? Y equals k into sine of half x, right? That was the original curve. Let me write that here. Y equals k into sine of half x. Let's apply these two transformations. First of all, you have to translate 2 units in the negative y direction. So to the whole function, from the whole function, you subtract 2, right? Translation means plus minus something. Vertical transformation means you have to do something outside the whole function. So outside the whole function, you subtract 2. That is what happens when you do this translation of 2 units in the negative y direction, 2 units down. Then what you have to do is, after that, you have to reflect in the x-axis. That means it's a vertical reflection, right? I told you why it's vertical. That means something is going to happen to the whole function. Now what we do is, after this first transformation, in the second step, what we can do now is we can say, let's multiply the whole thing by -1. So it becomes k into sine of half x minus 2 whole multiplied by minus. What does that give you? This gives you 2 minus k into sine of half x. This is the equation of the new curve that you get after transformation. Okay, so this is what you have after translation. This is what you've got after reflection in the x-axis. That is one thing that we've got to do. Then it says determine the coordinates of the point on the new curve corresponding to A. Okay, let me answer the questions first. Okay, so first of all, Abdullah, in the previous part, yes, you could differentiate it and put that equal to 0, but notice it's only 1 mark. So you should be able to figure it out without differentiation. But if you want to do that, you can do that. You can get the x coordinate using that as well, and that will work. That should work. Okay, now in the second part, you're saying, don't we put the negative sign only with k? Shouldn't we put the negative sign here? No, it's a vertical transformation. It's a vertical reflection. Vertical reflection means something has to happen to the whole function. So with the whole function, we put a negative sign. So minus has to be multiplied with the whole thing. Okay. What you are saying, so you're saying minus should only be with k. That would happen if it was the other way around. If reflection was happening first, then what you would do would be you would put a minus sign with k sine half x. And then after that, you can do reflection, and that will be -2. But this is different. In this case, the order is different. You first have to do translation. After you're done with translation, this is what you end up getting. Now, this whole thing has to be reflected. So you put negative sign outside. Okay, so that's the equation that you get at the end. All right, now determine the coordinates of the point on the new curve corresponding to A. So what was the point A earlier? The point A we figured out was 3 pi and minus k. 3 pi and minus k. Now, both of these transformations are vertical transformations. So nothing is going to happen to the x coordinate. X coordinate remains the same. It remains 3 pi. 3 pi. What about minus k, the y coordinate? We first have to do a translation of 2 units in the negative y direction. So it first becomes minus k minus 2, right? We subtract 2 from the whole thing. And then it's a reflection in the x-axis. That means the y coordinate gets multiplied with negative. So this is going to become k plus 2. So the final coordinates that you get from this for A, are going to be 3 pi and k plus 2. This is where point A is going to be. And this is going to be the equation of the transformed curve. All right. Miriam, you need to be specific. Which part specifically? Which step in particular? the new coordinate. Okay, so if you understand what we are doing here, we're doing exactly the same thing to this point now. There are two transformations that are happening. So when you do translation, whatever was the original y coordinate, since you have to go 2 units down, that would become y minus 2, right? And then in the next step, it's a reflection in the y in the x-axis. That's a vertical reflection. So if it was y earlier, it would become minus y. In this case, it's y minus 2. You get minus into y minus 2. These are exactly the two steps that we're applying here. We're saying y coordinate was minus k. So first of all, when we do translation of 2 units down, you say it's going to be minus k minus 2. That's the first thing you do. Because of that translation, you do minus 2 here, just like you were doing minus 2 here. And then because of the reflection, we're multiplying the whole thing by negative. So it basically becomes minus into minus k minus 2, which gives you k plus 2. So in the second step, you're multiplying by this negative sign. This time, we're multiplying by the negative sign here. And that gives you the final result. That's the new coordinate. All right. Okay, that was part B. Let's move on to the next question. Now it says a curve is such that dy over dx is equal to 3 into 4x plus 5 whole raised to power 1 over 2. It's given that these 2 points lie on the curve. Find the value of a. Now we've got 2 points on the curve. That means if we were to put them in the equation of the curve should be satisfied. So first of all, what we can do is we can find the equation of the curve and see what that turns out to be. We've got the derivative dy over dx, that equals 3 into 4x plus 5 whole raised to the power 1 over 2. How do you go from dy over dx to y? You have to integrate this. So it becomes y equals 3 into, so 3 remains as it is. That's a constant multiplying. 4x plus 5 whole raised to the power, you add 1 to the power, 1 over 2 plus 1. So that becomes 3 over 2. You divide by that new power. So you divide by 3 over 2. And you also divide by the derivative of what is inside. And that's 4. That's your integration. But remember, whenever we integrate, we have to put a plus c. So we got a plus c outside here. That's the function. Now let's simplify this a bit. This 4 and this 2, they get cancelled to give you 2 here. 3 and 3 get cancelled. And you're left with y equals 4x plus 5 whole raised to the power 3 over 2 divided by 2 plus c. That's the equation of the curve, but this is in terms of c. First of all, what we can do is we can find the value of c by inputting this point, 1 and 9. We know this point that lies on the curve. Let's put that point here. Put the point 1 and 9. What does that give us? That gives us 9 equal to 4 into 1 plus 5 whole raised to the power 3 over 2 divided by 2 plus c. Please make sure that you do this calculation with me. Let me know what the value of c turns out to be. What's the value of c that we get? 9 raised to the power 1.5 divided by 2. 9 minus the answer. Is it minus 9 over 2? Yeah, so minus 9 over 2. That's the value of c that we get from this. Okay, now let's input that back here. The function therefore becomes 4x plus 5 whole raised to the power 3 over 2 divided by 2 minus 9 over 2. That's the function that we've got. Now that we've got the function, 5a is another point that lies on the curve. The x coordinate of this point is 5. We need to find the corresponding y coordinate. How can we do that? Just put that point inside this curve now. And that is going to give you the value for a. So what's the point? Point is 5 and a. 5 and a. Y coordinate is 5. And y coordinate is a. And the x coordinate is 5. Let's just put that inside this curve's equation now. That gives you a equals 4 into 5 plus 5 whole raised to the power 3 over 2 divided by 2 minus 9 over 2. And now you can see what this turns out to be. You'll get the value of a from this. Okay, 58. Okay, so I've got multiple answers here that's saying 58. Okay, so this turns out to be 58. That's the value of A that we're getting. Thank you. So this is question number 3. Okay, make sense? Let's move on to the next one now. Now it says, prove that this identity is true. How do we do that? The left side looks more complicated. Let's start from that. Let's start from the left-hand side and see what that gives us after simplification. Okay, so we've got sine theta plus cos theta whole squared minus 1 divided by cos squared theta. Now, don't confuse this with sine square theta plus cos square theta. This is not the same as 1, okay? Sine theta plus cos theta whole squared. First of all, what you can do is you can expand it. Let's expand it and see what that gives us. This is a plus b whole squared, right? So after expansion, it's going to be sine square theta plus cos square theta plus 2 sine theta into cos of theta whole divided by cos square theta. That equals, in fact, that's identical to 2 tan theta. Okay. We have to show that this becomes 2 tan theta eventually. What do we do now? Sine, so we also have a minus 1 outside. I was about to do my first careless error for the day. This was minus 1, okay? Sine square theta plus cos square theta plus 2 sine theta into cos theta minus 1 divided by cos square theta. Now, what's this? Sine square theta plus cos square theta, this is going to be 1. So it becomes, this part becomes 1, right? 1 plus 2 sine theta into cos of theta minus 1 whole divided by cos square theta. 1 and minus 1, they get cancelled. And we're left with 2 sine theta cos theta over cos square theta. Now it's only one term in the numerator, so we can do some cancellation. Cos gets cancelled with 1 power of cos in the denominator. We're just left with 2 sine theta over cos theta, which is tan theta. We've got 2 tan theta, and that's what we wanted to prove. This is the same thing as the right-hand side. And that's the identity proof. Okay. Now it says, hence solve this equation. Now, what's similar in these two? What's similar in this equation to what we have done in the first part? The left part of this equation is exactly this thing. We have simplified that to 2 tan theta already. So what you can do is, you can write this equation as 2 tan theta equal to 5 tan cube theta. That's the equation that you get from this. That's from minus 90 degrees to plus 90 degrees. That's the interval that we're given. Now, do not divide by tan theta. Don't divide by tan theta, because what if tan was 0? So division by tan is not allowed. The proper way of doing this would be, you take 2 tan theta to the other side so that it becomes 5 tan cube theta minus 2 tan theta equal to 0. And now you take 1 tan common, and that leaves you with tan theta into 5 tan square theta minus 2 equal to 0. And now it's a product. That means either tan theta equals 0 or 5 tan square theta minus 2 equals 0. You've got these two equations. You can solve these two equations separately, and they will give you the possible values of theta. Now let's look at the first one. Tan theta equals 0. When is tan theta 0 in this interval? You could think of the graph if you want. It's when theta equals 0 degrees. That's one possible answer that you're getting. Okay, because at 90, it goes towards infinity. At minus 90, it goes towards negative infinity. So that means at both minus 90 and plus 90, it's undefined. All right. So theta equals 0. What about the other equation? From the other equation, we get tan square theta equal to 2 over 5. Okay. And now we take square root on both sides. When we take square root, remember, we have to put plus minus. Okay, square root of 0.4, and that's giving me plus minus 0.63246. Use use at least 4 significant figures. More, the more the better, right? But not less than 4 significant figures. Now you have to find the basic angle. How do you find the basic angle? You say tan alpha equals whatever is this angle, whatever is this number in positive. You make it positive first, basically. So 0.63246. And now you find the basic angle. Remember, your calculator has to be in degrees mode. Okay. Let's see what we get from this. Make sure your calculator is in the correct mode. It should be in degrees. Tan inverse of 0.63246. What are we getting? I'm getting 32.31 degrees. Okay. 32.31 degrees. That's the basic angle that we're getting. And now we think of quadrants. Which quadrants can we be in? Tan could be positive, it could be negative. So both possibilities are there. So that means it could be any of the four quadrants, 1, 2, 3, 4. However, since our interval is from minus 90 to plus 90, second quadrant is not possible. Third quadrant is not possible. The basic angle would either be here or it would be here. Remember, since your interval is also in the negative direction, you also have to check in the clockwise direction if there's any angle in your interval on that side. So now, what are the possible angles? You could either have this angle on the positive side, or you could have this angle on the negative side. So there are two possible values of theta that you're getting from this. You say theta is either equal to 32.3 degrees. Do we have a level of accuracy given here? No. Or theta equals minus 32.3 degrees. So we've got three answers to the solution. The three answers to the solution, 32.3, 32.3, minus 32.3, and 0. These are three possible answers that we get for this. All right. Ali, I'm not sure what you mean by that. How can you break the middle term here? Because you've got a cube term and a linear term. Are you talking about this? How would you break the middle term here? There's no middle term. I'm not sure if I understand you correctly. So if you did a plus b into a minus b, that thing, that's perfectly okay. That should give you the same result. You can do that, and that's okay. All right. So theta equals 0 and theta equals 32.3 and minus 32.3. These are the three answers that we're getting. Okay. Do not miss out on 0. All right. Let's have a look at the next part now. The next question now. Question number 5. It says a curve has the equation y equals 3 over 2x squared minus 5. Find the equation of the normal to the curve at the point 2, 1, giving an answer in the form ax plus by plus c equals 0, where a, b, and c are integers. Okay, now how can we do this? We've got the equation of the curve. We need to find the equation of the normal to the curve. That's what we're looking for. Remember, it's the standard process of finding the equation of the normal. You need a point. Well, you already have the point. The only other thing that you want is the gradient of the normal. How would you do that? You'll find the gradient of the curve at that point, take negative reciprocal of that, and that will give you the gradient of the normal at that point. How do you find gradient of a curve at a particular point? You have to find the derivative for that. Let's write the curve in this form first. It becomes 3 into 2x squared minus 5, whole raised to the power minus 1. And now let's find the derivative for this. dy over dx. 3 into minus 1, you multiply by the power, so it becomes minus 1. 2x squared minus 5 inside remains as it is. Subtract 1 from the power, minus 1 becomes minus 2, and then you multiply with the derivative of this part. That is 4 times x. Now let's simplify this. This gives us minus 3 and 4, that's minus 12 times x divided by 2x squared minus 5 whole squared. If I write this whole thing in the denominator, the power would become positive, and this is what we end up getting. All right, that's the derivative. dy over dx. Now we need to find the gradient of the curve at this point. What's the point? The point is 2, 1. You put x equals 2 here and see what that gives you. When x equals 2, you've got minus 12 into 2 divided by 2 into 2 squared minus 5 whole squared. What do we get from this? What's this result? Minus 8 over 3. Okay, good. Thank you. Minus 8 over 3. This is the gradient of the curve at this point. Okay. What about the gradient of the normal at this point? We would just take negative reciprocal of this. Okay. So the gradient of normal, that is going to be 3 over 8 negative reciprocal of that. So now we've got the gradient. We already had the point given. The point was 2 and 1. These were the coordinates of the point. We can write down the equation of the normal. It's a straight line. Y minus y1 equals m into x minus x1. Let's just input values in this. You get y minus 1 equal to m, which is 3 over 8 into x minus 2. And that's the result that we get from this. Okay. But now, if they had not asked you to give your answer in a particular form, you could leave it like this and that will be acceptable. However, in this case, they have asked you to write down the equation in this form. You want all terms on one side and only 0 on the other side. And there's another condition as well. A, B, and C, all of them have to be integers. So there should not be any fractions in your equation. Okay. So now we need to change the form of this equation. How do we do that? We can multiply 8 on the other side. That will simplify things. And that gives us 8y minus 8 equal to, on the other side, you got 3 into x minus 2. That gives us 3x minus 6. Take everything to the left side or the right side, or it doesn't matter. If I take everything to the right side, that gives me 3x minus 8y minus 6 plus 8 equal to 0. And the equation becomes 3x minus 8y plus 2 equal to 0. That's the equation of the normal that we were looking for. Okay, that was question number 5. Make sense? Let's move on to the next one then. All right, good. Question number 6. Now it says it's given that the coefficient of x cubed in this expansion is 432. Find the value of the constant a. Now, what's the binomial expansion formula? It's written in the formula sheet as well. Let me just write that here. A plus b whole raised to power n. That is n, or let me actually copy that here. A raised to power n plus nc1 into a raised to power n minus 1 times b plus nc2 into a raised to power n minus 2 into b squared, and so on. That's what the formula looks like. Okay. You can take a snapshot quickly, Ali. All right, good. Question number 6. A plus b whole raised to power n. This is the formula that we've got. Now we're given the coefficient of x cubed in this expansion is 432. So we need to find the coefficient of x cubed in this expansion. How do we do that? We first need to think about which terms we need to multiply for these two expressions to get x cubed at the end. Now, one possibility could be, if you're unsure, if you're confused, you could just expand this fully. It's only going to be 5 terms. It's not going to take that much time. You can expand it fully. Or a more efficient way of thinking about this would be in the other expression, the one that does not have any power on it, you've got 2 terms. One term is the constant term, 5, and the other is x power 1 term. The result that we want is x cubed. So what do we need to multiply 5 by to get x cubed? Constant will need to get multiplied by x cubed. So this is one term that we are looking for in this expansion. And a power x, that a into x, that means x power 1. What do we have to multiply x power 1 by to get x cubed? We need to multiply it by x squared. So we need these 2 terms from that expansion. We can ignore everything else. Okay, so we don't need anything else from this expansion. So when we expand it, just focus on those 2 terms. Once you have those 2 terms, stop expanding. You don't have to expand the whole thing. Okay. However, since this expansion is not that difficult, even if you wanted to do the whole expansion just to be on the safer side, you can do that, and that's perfectly okay. 2 plus ax whole raised to power 4. Let's expand it. What do we get from this? 2 raised to power n, that means 2 raised to power 4, plus nc1, that's 4c1 into 2 raised to power 3 into ax whole power 1. What do we want? Remember, x squared and x cubed. So we have 4c2 into 2 raised to power 2 into ax whole squared. This is the first term that we're looking for. We've got x squared here. And then the next is going to be 4c3 into 2 raised to power 1 into ax whole cube. This is the second term that we're looking for. We can stop at this point and we can say these were the two terms that we were looking for. Let's just simplify these two and see what we get from that. 4c2, what's that? 6. 6 into 4, that's 24. So this is going to be 24a squared x squared. 4c3 is 4. 4 into 2 is 8. So that's 8a cubed into x cubed. These are the important terms from that expansion. And now we just multiply those two things. We say 2 plus ax whole raised to power 4. This needed to be multiplied by 5 minus ax. What are we getting from that expansion? 24a squared x squared, ignoring the rest of the terms, plus 8a cubed into x cubed, again ignoring the rest of the terms. This has to be multiplied by 5 minus ax. Now, what multiplication do we need to do here? We don't necessarily need to multiply the whole thing. Just multiply the terms that are going to give you x cubed. So what you can do is this x squared term, this can be multiplied with minus ax, right? Because that's going to give you x cubed. And you can multiply this thing by the constant and forget about the rest of the multiplication. Again, you can do that if you want, but to make it more efficient, you can just multiply these two corresponding terms. So that gives you 24a squared x squared multiplied by minus ax plus 8a cubed into x cubed multiplied by 5. Let's simplify this. What do we get? Minus 24a cubed into x cubed plus 40a cubed into x cubed. Let's simplify this. This gives us 16a cubed into x cubed, and we've got the coefficient of x cubed that we were looking for. They told us that the coefficient of x cubed in this expansion is supposed to be 432. So all we have to do now is equate this thing to 432. Okay, equate this to 432 and see what that gives you. 16a cubed equals 432, and that gives you a cube equal to 432 divided by 16. That's 27. You take cube root of that. That gives you a equal to 3. That's the value of a that we were looking for. Okay, that's question number 6. Any problems with this? Make sense? Okay, good. Let's look at the next part now. The next question, that's question number 7. It says the straight line y equals x plus 5. It meets the curve 2x squared plus 3y squared equals k at a single point P. Find the value of the constant k. So we've got a straight line and we've got a curve. They meet at a single point P. What does that mean? You've got one linear equation, one quadratic equation. They're meeting at one single point. Does that remind you of something? There's only one solution. That means b square minus 4ac, that has to be equal to 0. We're talking about quadratic curve here. It's not exactly a standard quadratic curve at this point. However, if you were to start solving it simultaneously, you would get a quadratic function from that. So these two functions, they meet at one single point. How do you find that one single point? You would start by solving these two equations simultaneously. Now, how can you do that? You've got equation of the curve that's 2x squared plus 3y squared equals k, and the equation of the line that's y equals x plus 5. We often like making the same variable the subject in both equations and then equating them. But in this case, if we were to try making y the subject here, we would have plus minus. So it's better to just do substitution here. So you would say, let's input y equals x plus 5 in this equation. Right? That's how simple substitution works. Put y equals x plus 5 in this equation. What does that give you? That gives you 2 into x squared plus 3 into x plus 5 whole squared equals k. Let's simplify this. 2x squared plus 3 into x squared plus 10x plus 25 equals k. Let's simplify this further. This gives us 2x squared plus 3x squared plus 30x plus 75 minus k equals 0. All right. And that gives us 5x squared plus 30x plus 75 minus k equals 0. And now we've got a quadratic equation. In this quadratic equation, they're saying since there's only one solution at the end, there's only one point where they meet each other, we can say b square minus 4ac should therefore equal 0. And that's what we use here. What's the value of a? The value of a would be 5. The value of b would be 30. And whichever term does not have a constant, does not have x, that's constant. So c is equal to 75 minus k. Okay. Now let's just input values in b square minus 4ac. That gives us 30 whole squared minus 4 into 5 into 75 minus k equal to 0. 30 squared is 900 minus 20 into 75. 20 into 75 minus 1500 plus 20 into k, that equals 0. And that's going to give you the value for k. You can see what that turns out to be. Minus 600, that goes to the other side, becomes 600 divided by 20. The value of k is 30. All right. Make sense? Any problems with this? Ali, but you should not do that. Whenever you take square root, you should always put plus minus. So if you were to take square root here, you would have to deal with both cases. You'll have to deal with the negative case as well. You can't just assume that you have a positive result, positive square root only. If it was cubic, then we can't use b square minus 4ac, of course. This is a quadratic. B square minus 4ac only works for quadratic functions. It does not work for any other kind of function. Okay. All right, so that's the value of k that we get. Now, find the coordinates of P. P is the point where these two functions meet each other. How do you find the point where two graphs, two functions meet each other? We just solve them simultaneously. We've actually done most of that process here already in the first part. We got to this point, right? We got to this point when we equated both of them. It's just that we had our equation in terms of k there. So rather than doing all of that process all over again, you can just use this and continue from here. You have 5x squared plus 30x plus 75 minus k. Now you know the value of k as well. The value of k is 30. This equals 0. Let's see what we get from this. 5x squared plus 30x plus 45 equals 0. We can divide the whole equation by 5 to get x squared plus 6x plus 9 equals 0. Can we factorize this? It becomes x squared. In fact, it's a perfect square. If you can figure that out, you can write it as x plus 3 whole square directly. If not, you can do middle term breaking like this. X squared plus 3x plus 9 equals 0. And that gives you x plus 3 into x plus 3 equals 0. And the value of x turns out to be negative 3. It was expected. We were supposed to have only one value of x. We have only one value of x. Now we need to find the corresponding y coordinate as well. How do we do that? Put that back in any one of those equations. It's simpler to put that in the linear equation, y equals x plus 5. What does that give us? Y equals x plus 5. That means minus 3 plus 5. The y coordinate turns out to be 2. And the point that we were looking for, that's minus 3 and 2. It's been a pretty straightforward paper until this point, right? Let's see what's coming ahead. Apart from the transformation question, the second question, it's been fairly straightforward, I think, right? That was part B. Make sense? Any problem with this? No? Yeah, so these are the coordinates of P. Yes. Okay. Now, question number 8, it says an arithmetic progression in AP is such that its first term is 6. So first of all, let's write that down here. It's an AP arithmetic progression. Its first term is 6. That means it starts from 6. And the 10th term is 19.5. So we can say A equals 6 and T10, the 10th term, that is 19.5. Be very careful with decimals in your paper, because you have these dotted lines. Sometimes when you put a decimal on this line, you can end up missing that at the next step. That's what happens in that's what happened in one of our earlier papers. I missed a decimal somewhere. So make sure to write decimal above the line so that it's clearly visible. Okay, so T10 equals 19.5. That's what we're given. Now it says find the sum of the first 100 terms of this AP. Now, what's the sum formula for an AP? It's half n into 2a plus n minus 1 times the difference. You could use this or the other formula, but for that you'll need the 100th term as well. It's easier to use this one. Now, what do you need for this? If you want the sum of the first 100 terms, n is 100, a is 6. The only problem is we do not know what the value of b is. So we need to find the difference. How do you find the difference? For that, you're given the 10th term of the sequence. You can use the term formula. You can say Tn equals a plus n minus 1 times the difference. That means T10 should be equal to 6 plus n minus 1. That's 9 times the difference. T10 is 19.5. 19.5 equals 6 plus 9d. You can find the value of d from this. What's that? 1.5, right? 3 over 2 or 1.5. That's the value of d that we're getting. Put that in that sum formula, and that gives you 1 over 2 into n, which is 100, because we're looking for the sum of the first 100 terms, into 2 times a, which is 6, plus n minus 1, that means 100 minus 1, that's 99, times the difference, that's 1.5. Put this in your calculator and see what that gives you. 8025. Okay, so can somebody else confirm this as well? So we have multiple results to verify. 8025, 8025. Okay, so I'll just trust that. I'll say this is 8025. Okay. Sum of the first 100 terms, that's 8,025. Okay, good. Thank you. So that's the first part. Now it says a GP, a geometric progression, A1, A2, A3, and so on, is such that A1 equals 24, and the common ratio is 1 over 2. Okay. So we have the first term, that's 24, and we have the ratio, that's 1 over 2. The sum to infinity of the GP is denoted by S. Okay, sum to infinity is denoted by S. The sum to infinity of the even numbered terms, A2, A4, A6, is denoted by SE. 19.5, 19.8. Okay, I'm not sure if I want to hear myself back. Can everyone mute themselves, please? Batul, Huzaifa. Huzaifa. Okay. The sum to infinity of the even number terms, A2, A4, A6, that's denoted by SE. Find the values of S and SE. So sum to infinity of the first GP. Okay, let's start with that. Sum to infinity of that GP. So we have a geometric progression, and the first term is 24, right? In fact, they're using A1, A2, etc. later on. So let's write it like this instead. We say this is A1, and this is A2, A3. You've got the first term, that's 24. And now the ratio is 1 over 2. Can you write down the sum to infinity of this? A over 1 minus R, A is 24, divided by 1 minus R, that's 1 minus 1 over 2. And that will be 48, right? Yeah, so it should be 48. Sum to infinity for the first GP is 48. They called it S, so we can say the value of S is 48. That's one thing that we were looking for. Now it says the sum to infinity of the even numbered terms, A2, A4, A6. What that means is the terms that are occurring at even position, the terms that are coming at even positions. Now, let's try to understand that. What does that first GP, the first geometric progression, look like? Let's call this GP number 2. In fact, the same GP. A1, A2, A3, A4, A5, A6. Let's write some of these terms and write down the values that we've got for them. A1 is 24. Since the ratio is 0.5, what's the next term going to be? 24 into 0.5, that's 12. And then 6, 3, 1.5, 0.75, and so on. What they're saying is they want you to find sum to infinity of the even numbered terms. That means sum to infinity of all of these terms. This term, this term, this term, and so on, right? Is A8, A10, A12, and so on. What you can do is you can treat this as a new sequence. Just take out these terms. So you say you have a second geometric progression now. Let's call this GP2. And it looks like this. Its first term is 12, and then it's 3, and then it's 0.75, and so on. What's the first term of this GP? The first term of this GP is 12. What's the ratio of this GP? Take any two consecutive terms, divide them 3 over 12, and that gives you 0.25. You can divide these two as well, 0.75 over 3, that also gives you 0.25. Yeah, so that's the ratio. Ratio is 0.25. You've got the first term, you've got the ratio. Now you can find the sum to infinity of this sequence as well. Let's see what that turns out to be. A over 1 minus R, A is 12 over 1 minus 0.25. That will be 12 divided by 0.75, and that's 16. So sum of the even numbered terms, that is 16. That is the second thing that we were looking for. Sum of all the terms in the sequence would be 48. If we just add the even numbered terms, that will be 16. If we had to add the odd number terms, that will be 48 minus 16, 32, but that's not what we're looking for. We've got sum of all the terms and the sum of the even numbered terms. All right. I hope that makes sense. That was question number 8. Let's move on to the next one, question number 9. How many questions do we have in this paper? 11. Okay, so we have 3 questions left. Question number 9. Now it says functions f and g are defined for all real values of x by f of x equals 3x minus 2 whole squared plus k, and g of x equals 5x minus 1, where k is a constant. Given that the range of the function gf is greater than or equal to 39, gf of x is greater than or equal to 39, find the value of k. Okay, now how do we think about this? Gf function. First of all, let's find out what the gf function is. Gf of x. What would it look like? G of f of x. That means inside g, we've got to input f. So it becomes g of 3x minus 2 whole squared plus k. Okay. And now that gives us So inside this function, wherever you've got x, you've got to replace that with this whole thing. What do we get from this? 5 into 3x minus 2 whole squared plus k minus 1. This is what we get. This is the function g f of x. Okay. Now let's simplify this a bit. Let's multiply 5 inside, and that will give you 5 into 3x minus 2 whole squared plus 5 times k minus 1. This is what we end up getting. And now you see, what are they saying? They're saying the range of this function is greater than or equal to 39. That means the y values of this function, they have to be 39 or above, greater than or equal to 39. Now it's a quadratic function. How do you find range of quadratic functions? You have to think of the sketch of the graph, right? And see how that looks like. And look at the domain of the function. What's the domain of the function? Domain of f and g, both of them are all real values of x. So that means the composite function, the domain of that composite function is also all real values of x. So what's the range? It's a quadratic function. Is it going to be a U-shaped curve or an N-shaped curve? It's a U-shaped curve because the coefficient of x squared is going to be positive. It's going to be a curve that looks like this. Okay. They are saying the range of the function is greater than or equal to 39. That means the lowest point of this graph, that is supposed to be 39, because that is when the range of the function would be greater than or equal to 39. Right? Range represents the y values. And that means the y coordinate of the turning point, therefore, has to be 39. The y coordinate of the turning point has to be 39, because that is when the range of the function would become greater than or equal to 39. Right? If the lowest point is 39, that's when the range would be 39 or above. How can you find the turning point from this function? This part outside, it's the completed square form, although it's not the standard form because we've got the coefficient of x here inside as 3. But outside, we've got 5k minus 1. This is going to be the y coordinate of the turning point, and that is 5k minus 1. This is the y coordinate of the turning point. What about the x coordinate? For the x coordinate, you would have to put this thing equal to 0. You don't need that here, but in case we need that later, maybe let's just write that down if we need it later. What's the x coordinate? We would put this equal to 0. 3x minus 2 equal to 0. X equals 2 over 3. So the coordinates of this turning point, they are going to be 2 over 3 and 5k minus 1. These are the coordinates of the turning point. Now we know the y coordinate is supposed to be 39, right? So all we have to do is equate these two things. We say 5k minus 1 has to be equal to 39, because this is basically the turning point of the graph. And that gives you k equal to 40 over 5, which is 8. And that's the value of k that we were looking for. Okay, yes, Batul.
So why did we equate 3x minus 2 to 0?
To find the x coordinate of the turning point. We don't need that here, but in case we needed that later on, if in case we need that later on at some point, I'm just writing that down here. It's not needed here. It's not required here. It's just something extra that I'm just writing here.
So why didn't we just equate the entire g of x greater than 39, and then solve it?
That could be something that you could try. You could say 3x minus 2 whole squared. No, in fact, g f of x, the function that we were getting at the end, 5 into 3x minus 2 whole squared plus 5k minus 1. Since the range is greater than or equal to 39, you could say this whole thing has to be greater than or equal to 39. But the problem is we can't really solve this inequality because we've got two unknowns. We've got x here and k here. So we can't solve this as an inequality directly because there are two unknowns. So we have to make sense of what the range of the function means in this case. the range of the function being greater than or equal to 39 means that the y coordinate of the minimum point of this function that has to be 39. So you have to basically relate it to the turning point. Otherwise, if you try and solve this as an inequality like this, we have two unknowns. How would you solve that? That would be a problem, right?
Okay,
If it
so
was if it was only one unknown, we could try solving that inequality, but in this case, we can't do that. All right, that was the first part. Now let's look at the next one. It says, for this value of k, determine the range of fg. So now that we know the value of k, they're saying the value of k is supposed to be taken as 8, what you found in the previous part. Determine the range of fg. Okay, fg. Let's first of all find the function fg. What is fg going to be? F of x is equal to 3x minus 2 whole squared plus k. In place of k, we can input 8 here. That's f of x. And g of x is 5x minus 1. Both of these functions are valid for all real values of f. Okay. Now let's find the function fg first of all. Fg of x. What is that going to be? F of g of x. Inside f, you input the function g, and that gives you f of 5x minus 1. What does that give you? That gives you 3 into 5x minus 1 minus 2 whole squared plus 8. So what I'm doing is, in place of this x, I'm inputting 5x minus 1. So it becomes 3 into 5x minus 1 minus 2 whole squared plus 8. Okay. Now let's simplify this. This gives us 15x minus 3 minus 2 whole squared plus 8. And that simplifies to 15x minus 5 whole squared plus 8. We are looking for the range of this function fg. Now, again, it's a quadratic function. Fg of x, it's a quadratic function. It's a U-shaped graph, which is going to look like this. What's the turning point of this graph? Y coordinate of the turning point is 8. That's all that we're looking for. We don't really need the x coordinate. If we had to find that, that will be x equals 5 over 15, which is 1 over 3. But whatever the x coordinate is, we say the y coordinate is 8. So what about the range of the function? Remember, this function is valid for all real values of x. That means the whole part of the function is valid. What's the range? If the minimum point is at 8, you can say the range of the function is y greater than or equal to 8. That's the range of the function. You can write it like this, or you can say f g of x greater than or equal to 8. You can write it both ways. You can say y greater than or equal to 8 or f g of x greater than or equal to 8. That's the range of this function. Okay, just treat it like a normal quadratic function and then find the range of that quadratic function like you would normally do. Okay, let's move on. B square minus 4ac. Where exactly, Josefa? Okay, I'm sorry, I'm just taking some of those start messages with A2 and A3. Which part are you talking about? Part A? Okay, here. Okay, all right. That could be another way of thinking about this. That could be another way of thinking about this. That should work as well. Although it would be easier to understand this one, I think, rather than B square minus 4ac. But that's also something that you could try. Now we get A2 and A3. Where are they? Achha, that was, I think, way back somewhere. Mariam, A2 and A3, we just got them by multiplying by the ratio. Ratio was 0.25, we just 0.5. In order to get the next term, we just multiplied by 0.5. So 24 into 0.5, that gives us 12. 12 into 0.5, that gives us 6, and so on. All right, so that's how we're finding the next terms. Okay. All right. Yes. Batul, can you mute yourself again? I can't find the option to mute you from here, unfortunately. Okay, now I find it. All right, good. That was part B. Now, in the next part, it says, the function h is defined for all real values of x, and it's such that gh of x is 35x plus 19. Gh of x is 35x plus 19. This is what we're given. Okay, find an expression for g inverse and hence or otherwise find an expression for h of x. Now, how do you deal with problems like these? You've got the function g of x. What was g of x? G of x was 5x minus 1. You say let y equals g of x, and that gives you y equals 5x minus 1. You make x the subject, and that will give you y plus 1 over 5. And the function g inverse, that turns out to be x plus 1 over 5. This is g inverse. Okay. Now we are given that gh of x is 35x plus 19. All we have to do is make h of x the subject here somehow. Now for that, what we do is we introduce g inverse on the left side. We have g here, right? In order to get rid of this g from here, we apply g inverse on the left side in the beginning. So it becomes g inverse of g of h of x. Okay, but we can't just apply g inverse on the left side. We have to apply it on both sides. We say g inverse of g of h of x, that equals g inverse of 35x plus 19. So basically, since we want to make h of x the subject, what we do is, in order to get rid of this g, we apply g inverse in the beginning on the left side. And since we're doing that on the left side, it's an equation. We have to do that on the right side as well. So on the right side as well, we say, let's apply g inverse here. And now g inverse of g, they cancel each other's effect, right? They're inverse functions. And on the left side, we're just left with h of x. So we have h of x equal to g inverse of this thing. G inverse of 35x plus 19. Now you know the g of x, g inverse function. In place of x, just put 35x plus 19, and that will give you 35x plus 19 plus 1 divided by 5. So in place of x, you put this thing. Inside the g inverse function, you've got to input 35x plus 19. And now you simplify this, and that gives you 35x plus 20 over 5. And then h of x will turn out to be 35 over 5. That's 7x plus 4. That is h of x. That's what we were looking for here. That's question number 9. Is that okay? That's question number 9. Let's move on to the next one.
Sir, I didn't understand like जब आपने composite functions को फिर h of x कैसे निकाला है मुझे ये नहीं समझ आया.
You understand this step?
No, I don't understand this step.
This is actually a standard process that we have in functions whenever you've got so it's very similar to what used to happen in matrices in O-levels, remember? What do you find that? Composite functions, yeah. So basically, if you have something like this, f h of x equals g of x, and you want to find h of x, the idea is to get rid of f from here somehow. How do you get rid of f? You get rid of f by applying f inverse in the beginning on both sides. When you do that, f inverse and f, they cancel each other out, and you're just left with h of x, and h of x therefore equals f inverse of g of x. Similarly, if you had something like this, kf of x equals g of x, and you have to find k of x in this case. Now, in this case, since you have f of x here, and you want to make k the subject, you want to somehow get rid of this f. How do you get rid of f? Again, by applying f inverse. However, since f is coming on the right side here, in order to get rid of this f, we apply f inverse after f, so that when they come together, they will cancel each other's effect. And do the same thing on the right side as well. So you have g of x here on the right side, apply f inverse after g on the right side as well. Now f and f inverse on the left, they get cancelled. We just left with k of x. K of x equals gf inverse of x. Now that's a standard process that you can use for anything like this, just like it used to happen in matrices. If you had a matrix A multiplying by B and the result was equal to C, and you had to make B the subject, what you would do would be you would multiply A inverse on the left side of the left side on both sides, right? And that will leave you with only B. So it works very similar to that. The only difference is in matrices we had to multiply matrices. In functions, we don't say we are multiplying, we are applying functions, but the concept is almost exactly the same. So that's the concept that we're actually using here. Since we had gh of x, we had to get rid of g of x somehow to get h of x. And for that, we applied g inverse on both sides on the left side. Okay?
Okay, thank you.
All right, let's move on. Question number 10. It says the diagram shows the circle with center C minus 4, 5. So we've got the coordinates of the center. They are minus 4 and 5. And radius under root 20. Radius of the circle is under root 20. This is under root 20. And this is under root 20. The circle intersects the y-axis. So this is the y-axis. That means the x coordinates of both of these points, they are supposed to be 0. Okay. At points A and B, the size of angle ACB is theta, radian, this angle is theta. This is what we are given. Okay. Now it says find the equation of the tangent to the circle at the point minus 6, 9. Okay, where's the point minus 6, 9? It's going to be, since the center is minus 4 and 5, minus 6 is going to be to the left of this and above somewhere. So maybe somewhere around here. Let's say the point minus 6, 9 is around here. We need to find the equation of the tangent at this particular point. How do you do that? This is the tangent. We need to find the equation of this. Do we have the point? Yes, it's a straight line. For finding the equation of straight lines, we just need two things: the point and the gradient. We've got the coordinates of the point. They're minus 6 and 9. What about the gradient? That's what we need to figure out somehow. How do you find the gradient? You've got the center of the circle. What you can do is you can make a radius from the center to that point, and that would look like this. This is the radius. Can you find the gradient of this radius? Let's call that point something as well. Let's name it something. Let's say this point is x. Let's find the gradient of cx. Gradient of cx, what would that be? 9 minus 5 divided by minus 6 minus 4. That becomes minus 6 plus 4. What's this gradient? 4 divided by minus 2. That's minus 2. That's the gradient of cx. What about the gradient of the tangent? Tangent is negative reciprocal of this. That will be 1 over 2. So we've got the gradient of that tangent. We already know the point through which that tangent is passing. That's the point minus 6, 9. We can just write down that equation. Y minus y1, that's y minus 9 equals m, which is 1 over 2 into x minus x1, that's x plus 6. And that's the equation that we were looking for. We can leave it like this because the question does not require us to write the answer in a particular form. So we can leave it like this and that's perfectly okay. Okay. Now it says find the equation of the circle in the form x squared plus y squared plus ax plus by plus c equals 0. Equation of circle, how do you find equation of circle? We need two things for that. coordinates of the center and the radius. You've got both of those things. You know the coordinates of the center, you know the radius. You can write down the equation. X minus a whole squared plus y minus b whole squared equals r squared. The coordinates of the center are -4 and 5. And the radius is under root of 20. What do we get from this? X minus -4, that becomes x plus 4 whole squared, plus y minus b, so this is a, this is b. Y minus 5 whole squared equals r squared, radius squared, that means under root 20 whole squared, that becomes 20. Now, we need to write the equation in this expanded form. So how do you do that? You just expand these squares and bring 20 to the left side as well. And that's going to give you x squared plus 8x plus 16 plus y squared minus 2 into 5 into y, that's minus 10y plus 25 minus 20 equals 0. And that gives us x squared plus y squared plus 8x minus 10y, 16, 25, and 20. Okay. That gives us 21, right? Plus 21 equals 0. That is the equation of the circle that we were looking for in this expanded form. All right, let's look at the next part now. It says find the value of theta correct to 4 significant figures. What's theta? Theta is this angle here. How do you find the value of this theta? Let's think about this now. Under root 20, under root 20. What have we found earlier? We got the equation of the circle. Okay, so what we can do is we can find the points A and B. How do you find points A and B? Points A and B are the y-intercepts of the circle. Can we find the y-intercepts of the circle? We've got the equation of the circle now. That's what it looks like. X squared plus y squared plus, in fact, it will be easier to use that other form. That will be quicker. X plus 4 whole squared plus y minus 5 whole squared equals 20. In order to find y-intercepts, all you have to do is put x equal to 0. When you put x equal to 0, what do we get from that? 0 plus 4 whole squared plus y minus 5 whole squared equals 20. Now, 4 squared goes to the other side. That becomes 20 minus 16, and that will be 4, right? Now you take square root on both sides, but remember, whenever you take square root, we have to put plus minus, so plus minus 2. That means y minus 5 equals 2, or y minus 5 equals minus 2. Y equals 7, or y equals 3. These are the y coordinates of the points A and B. So one of them has the y coordinate as 3, and the other one has 7. We need to find the angle theta. How can we do that now? We can make an isosceles triangle. We could use cosine rule as well if you wanted, but it's easier to use a right angle triangle like this. Divide this isosceles triangle into 2 parts such that this is the 90 degrees angle. Since this is 7, this is 3. This is going to be the midpoint. This is going to be 5. 5 to 7, this length is 2 units. This length is square root of 20. We can find this angle. Let's call this angle alpha. How do you find this angle? You can use sine for this. 2 is perpendicular. Under root 20 is hypotenuse. Let's use sine and see what we get from that. Sine of alpha equals 2 over under root 20. Over under root 20. And now I find the value of alpha from this. What does that turn out to be? Make sure your calculator is in radian mode. Unless the question uses degrees somewhere, you should always prefer radians generally. 2 over under root of 20. Sine inverse of that, 0.463648. That's the value of alpha that I'm getting. That's half the angle. So what about that complete angle? Just multiply this by 2. Theta equals 2 into 0.463648. And you can see what that turns out to be. Multiplied by 2, that's 0.927295. Four significant figures, it would be this. You have to write it as exactly this. If you write more than 4 significant figures, you lose a mark. If you write less than 4 significant figures, you lose a mark on that as well. So make sure to write exactly this, 0.9273. That is what we're getting from this. Okay, so after we found the y values, we got an isosceles triangle like this. Let me draw that on the side. This is what the triangle looks like. This is under root 20. This is 4 units. And this angle is theta. This is also under root 20. It's an isosceles triangle. So what I've done is I've divided the isosceles triangle into 2 parts. It becomes a right angle triangle. And just focused on one of these 2 triangles then. Let's focus on this part. This is the right angle triangle now. If the whole length was 4, this length is 2. So we are using this 2, this under root 20, and this alpha in that right angle triangle. Sine of alpha equals 2 over under root 20. You find the angle alpha from that, multiply that by 2, and that will give you that whole angle theta. Make sense? So yes, sine, cos, tan functions, they can only be used on right angle triangles. They're ratios, okay? In other triangles, you have to use sine rule or cosine rule, but that makes things complicated. It's easier to just use a right angle triangle like this. Okay, so that's part C. Now let's look at part D. It says find the perimeter and area of the segment shaded in the diagram. Yeah, make sure to keep revising. If you're forgetting anything, make sure to revise everything regularly. Revise the notes regularly. Okay, find the perimeter of the area of the segment. Okay, that's pretty straightforward. Now, what's the perimeter of this shaded part? There are 2 sides. One is this, that's 4 units. We already know that. What about this arc length? AB. You can find that now. You've got the radius, you've got the angle. You can find that arc length. Let's do that. Arc AB. Radius into angle. Radius was under root 20 into angle, that's 0.9273. S equals r theta, right? Arc length equals radius into the angle. Under root 20 multiplied by 0.9273, and that's giving me 4.147. Okay, that's arc AB. Now, what about the perimeter? 4.147, that's the arc length. The other boundary is that straight line, that's 4 units. So you add 4 to that. The perimeter becomes 8.147. That is one thing that we were looking for. The other thing that we want is the area of the segment. How do you find area of the segment? Area of segment is going to be equal to area of the sector, that's half r squared theta, minus the area of that triangle. So area of this whole sector minus the area of this triangle. Okay. Area of sector is half r squared theta. Area of triangle, we can use half AB sine theta, AB sine C. We've got 2 sides and the angle between them. Let's see what that turns out to be. R into sine of the angle between them. Okay. What do we get from this? Half into r squared. Radius was under root 20. So square of that into the angle. The angle is 0.9273. Minus 1 over 2 into r, that's again r squared. So that's under root 20 whole squared equals sine into sine of 0.9273. Again, make sure your calculator is in radian mode. While doing this calculation, and you can see what those turns out to be. 10 into 0.9273 minus 10 into sine of 0.9273, and I'm getting 1.27297 from this. That's 1.273. That's the area of the segment that we're getting. So we've got the perimeter and the area. That's what we were looking for. Any problem with this? Have you verified the calculations as well? Is that okay? No problems? Okay, good. Let's look at the last question then, question number 11. Now it says the diagram shows the curve with this equation for x greater than 0. The curve crosses the x-axis at points A and B and has a minimum point M. Find the exact coordinates of the minimum point M. M is the turning point. How do you find the turning point of a function? You differentiate it, put that equal to 0. It's not a quadratic function, right? So for quadratic functions, you have other methods as well. For any other function, you have to use differentiation. Let's differentiate it, dy over dx. What's the derivative of this function? 2 is multiplying, that remains as it is. Derivative of x raised to the power minus 2 over 3 multiplied by the power. Subtract 1 from the power, minus 2 over 3 minus 1, that will be minus 5 over 3, right? Minus 5 over 3, minus 3 into minus 1 over 3. Yes, Abdullah, it is a hidden quadratic equation, but first of all, we need to differentiate it. So we're not really using that idea for now. If we had to solve it to find, let's say, the x-intercepts, then yes, we would solve it as a quadratic, but we have to differentiate it first, okay? In this case, 3 into 1 minus 3 into minus 1 over 3 into x raised to the power minus 4 over 3. And then the derivative of 1 is just 0. Since we're looking for the turning point, we put this equal to 0. 0 equals minus 4 over 3 into x raised to the power minus 5 over 3 plus 3 and 3 get cancelled. And we have x raised to the power minus 4 over 3. Okay, this is what we get. Now we need to solve this equation somehow. How do we solve this? We can take the smaller power common, whatever is the smaller power. Or it's not necessary though, take any of these powers common. Let's say if I take x power minus 4 over 3 common, what does that leave me with? X power minus 4 over 3. If I take that common, what am I left with? Minus 4 over 3 into x raised to the power minus 1 over 3, right? You can verify that by just multiplying x power minus 4 over 3 with x power minus 1 over 3. Do you get this back? Minus 4 over 3 minus 1 over 3, that is minus 5 over 3. So that's fine. And then outside, the second term is just going to be plus 1. This is what we get. Now, it's a product. That means either x raised to the power minus 4 over 3 equals 0, or minus 4 over 3 into x raised to the power minus 1 over 3 plus 1, that equals 0. So 4 over 3 into x power minus 1 over 3 equals 1. And what we can do now is we can say it's 4x raised to the power minus 1 over 3 equals 3. And if I just take this to the right side, it will make the power positive, make things simpler. That becomes x power 1 over 3, or it can actually show another step to make it simpler. 4 over 3, and if I take x to the other side, that's going to be 1 over x power minus 1 over 3. And now I could take this negative power above and it becomes 4 over 3 equal to x power 1 over 3. All right, and now we need to find the value of x from this. How do we do that? We just cube both sides. We need to get rid of this power 1 over 3. Take cube on both sides. And that will give you 4 cubed, which is 64. 3 cubed, that's 27. That's the value of x that we're getting. And from the other one, we just get x equals 0. Because x power minus 4 over 3 can only be 0 when x equals 0. These are the 2 points that we are getting. Okay, now x, of course, cannot be 0. You can see it in the diagram. It's not 0. This is not possible. So the x coordinate of m that we are getting is 64 over 27. Now we need to find the corresponding y coordinate. How do you find the corresponding y coordinate? Put that back in this equation and see what that gives you. Okay, let's try that now. Let's put this back here and you would get y equal to 2x raised to the power minus 2 over 3 plus, minus 3x raised to the power minus 1 over 3 plus 1. Okay, now let's input that value of x. In fact, before that, if you want, you can. Or just leave it like this and that's okay. 2 into, since they want an exact answer, it's better to input values here. You have to show this working. 64 over 27 raised to the power minus 2 over 3 minus 3 into 64 over 27 raised to the power minus 1 over 3 plus 1. Okay, now calculate it step by step. What's the first thing that you get from this? 64 over 27 raised to the power minus 2 over 3. That's 9 over 16. 2 into 9 over 16 minus 3 into, when they want an exact answer, it's better to show as much working as possible to show how exactly you're getting that result at the end. 64 over 27 raised to the power minus 1 divided by 3, and that's giving me 3 over 4 plus 1. And now you can write down the final answer, the y coordinate. What does that turn out to be? 18 over 16 minus 9 over 4 plus 1. It's minus 1 over 8, right? It's not minus 9 over 8. Can somebody else confirm this as well? Ruqayya, did you forget to add 1? Yeah, so it's minus 1 over 8. Yeah, but thank you. That's the value of the y coordinate that we get. So what are the exact coordinates of m then? They are 64 over 27 and minus 1 over 8. These are the coordinates of m that we were looking for. Okay, that's the point m. Now it says find the area of the region bounded by the curve and the line segment AB. Area of the region. Okay, let me answer that question as well. What was that? How do we take power common? What's the smaller of these? In fact, just take any of the powers common. You either take this common or you take this common. You have to take one of the powers common so that one term becomes a constant. Okay. So I'm taking x power minus 4 over 3 common. You could also take x power minus 5 over 3 common. If I'm taking x power minus 4 over 3 common from x power minus 5 over 3, just subtract from minus 5 over 3 this power. What are we left with? Minus 1 over 3. That's what you get inside. Just like from x cube, if you take x square common outside, inside you're left with 3 minus 2. That's x power 1. So whatever you're taking common, you just subtract that power from this. You're taking minus 4 over 3 common. So minus 5 over 3 minus 4 over 3, that leaves you with minus 1 over 3 inside. Okay. All right, that was the first part. Now let's look at the second part. It says find the area of the shaded region. Find the area of the shaded region bounded by the curve and the line segment AB. Curve and the line segment AB. So basically, we're looking for this area. How do you describe this area? This is the area between the curve and the x-axis. Now, for that, we first of all need the limits from A to B. How do you find the limits? We have to put y equal to 0 for that. These are x-intercepts. Let's do that calculation here. Y equals 2x raised to the power minus 2 over 3 minus 3x raised to the power minus 1 over 3 plus 1. In order to find the limits, we put y equal to 0 because we're looking for the x-intercepts. Okay? Let's put y equal to 0. What do we get from this? 0 equals 2 into x raised to the power minus 2 over 3 minus 3 x raised to the power minus 1 over 3 plus 1. That's what we get. Now, look at the powers. They are in the ratio 1:2. So what that means is you can actually use a substitution to make it a quadratic equation because it's a hidden quadratic equation. You can look at the powers. They are in the ratio 2:1, right? If this is 2, this is 1. Whatever is the smaller power in terms of magnitude, you can say that is u. Let u equals x power minus 1 over 3. If that is the case, what about u squared? U squared would be equal to minus 2 over 3, x power minus 2 over 3. So this equation therefore becomes 2u squared minus 3u plus 1 equals 0. Now it's a quadratic equation. How do we solve this quadratic equation? We have to show the process for that, show the working for that. In this case, you could use factorization. 2u squared minus 2u minus u plus 1 equals 0. You get two factors from that, 2u minus 1 and u minus 1. So u equals 1 over 2 or u equals 1. Now you put that substitution back. You say either x raised to the power minus 1 over 3 equals 1 over 2 or x raised to the power minus 1 over 3 equals 1. Now we can take reciprocal on both sides so that this power becomes positive, and that will make things simpler. X power 1 over 3, that equals 2. And x power 1 over 3, that equals, reciprocal of 1 is also 1. So we've made the powers positive. I've just taken reciprocal on both sides. If it's x power minus 1 over 3, after taking reciprocal, the power becomes positive. And now we take cube on both sides. That means x either equals 8 or x equals 1. These are the limits that we're getting. So this point is supposed to be 1 and this point is supposed to be 8. Okay. Let's say if that makes some sense as well. 64 over 27, that was the x coordinate of the point M. 64 over 27, that's 2.37. So this point was supposed to be 2.37. So according to that, this 1 makes sense. This 8 also kind of makes sense. That's okay. So it's good to do a sanity check like this, that okay, on the graph, do these values make sense? In this case, yes, they do. 1 and 8, these are the limits. And now we just have to integrate it, input those limits, and we would get that area. How do you find area between a curve and x-axis? Integration of y with respect to x, limits are from 1 to 8. Now, what's the function? Let's input that here directly. It's 2x raised to the power minus 2 over 3 minus 3x raised to the power minus 1 over 3 plus 1. We need to integrate this with respect to x, input those limits. What's the integration of this? 2x raised to the power minus 2 over 3. Add 1 to the power minus 2 over 3. Minus 2 over 3 plus 1, that will be 1 over 3 divided by 1 over 3, right? Minus 3 into x raised to the power minus 1 over 3 plus 1, that will be 2 over 3 divided by 2 over 3 plus integration of 1 is x. And now we input the limits from 1 to 8 and see what that gives us. Let me just confirm the working. Add 1 to the power, x power 1 over 3, divide by that. And this is also correct, 2 over 3 and 2 over 3. Yeah, it looks okay. Now let's simplify this first before we input the limits. We can put 3, we can take 3 to the numerator. 3 into 2, that's 6. 6x raised to the power 1 over 3. Minus 3 goes to the numerator here as well. 3 into 3, that becomes 9. So we've got 9 over 2 into x raised to the power 2 over 3 plus x. Now we could input the limits from 1 to 8 and see what that gives us. Input x equal to 8. That gives us 6 into 8 raised to the power 1 over 3 minus 9 over 2 into 8 raised to the power 2 over 3 plus 8. Subtract from this the case when you input x equals 1. When you input x equals 1, you get 6 into 1 raised to the power 1 over 3 minus 9 over 2 into 1 raised to the power 2 over 3 plus 1. Now let's evaluate this and see what that gives us. The first bracket, 6 into 2 minus 9 divided by 2 multiplied by 4 plus 8. The first bracket is giving me 2. Subtract from this result from the second bracket, that's 6 minus 9 over 2 plus 1. And that's 5 over 2. And the result that I'm getting is negative 1 over 2. It's a negative result, which was expected because the area was below the x-axis. So this is negative 1 over 2. What are the values on the vertical axis? Minus 1 over 8. Okay, so I'm just making sense if the area could be that small because the y coordinate is very small. Minus 1 over 8, that is why the area is turning out to be that small, and minus 1 over 8, yeah, that will make sense. We had to find the area. This is turning out to be a negative result. We would say the area therefore is 1 over 2, and that is our final result. Okay, you can't have a negative area, just make it positive at the end, and that's 1 over 2. Okay. Okay, now let me just answer a quick question here. So you're saying, what if you found the limits by using the table function in your calculator? What you mean by that is, if you were to put this function in your calculator in the table function, and then what x values are you inputting? You're inputting maybe 0 to 10, and then taking some step. What exactly are you doing? What's the start value that you're taking? 0. What about end, and what about step? What are you inputting in the table function? Okay, yeah. Yeah, so if you're inputting end 10 and maybe step 1, you would get 0 at 1 and 8. That could be acceptable if you clearly show that when you input x equals 1, y turns out to be 0. You'll have to show that working. And then you input x equals 8 and show that y turns out to be equal to 0 for that as well. Show this working. Input these values of x in the function and get the corresponding values of y, and you would get the result. However, it only works in this case because the x-intercepts are integers. What if they were not integers? Then you'll have to follow this whole process. Okay. So in this case, that ends up working because the x coordinates were integers. But if you do this, then you have to show the working that for both values of x, the y coordinate turns out to be 0. That working will need to be shown on the exam paper. Okay, that was part B of this, and that's it. I hope that makes sense. Any quick questions before we end? Any problems, anyone?
Sir, can you explain the B part of question number 2?
What exactly in that? Atul, what exactly in this part? Did you join late?
It's the point, the new point. I can't understand.
Were you here on time or did you join late?
No, I was here on time, but I didn't understand it.
Okay, so otherwise, I was saying I could just upload the recording. You can have a look at that. Okay, so what exactly did you not understand? Because I explained it again as well. So basically, there are two things that are happening: translation of 2 units in the negative direction. So that means you have to subtract 2 from the y coordinate. So that's the first thing you do because it's a translation. 2 units in the negative y direction, you subtract 2. That gives you minus k minus 2. Original coordinate was minus k. You subtract 2 from that because of this first transformation. And then what's happening is you're doing reflection in the x-axis. Since reflection in x-axis means it's a vertical reflection. So the whole thing gets multiplied with negative sign. So you multiply the whole thing by negative, and that becomes k plus 2. Right?
Yes, understood.
Okay, good. Yeah, so it was a fairly easy paper. It would definitely be above 60 threshold, maybe around 62, 61, 62 at a minimum. All right, so that's it. I will see you again tomorrow. For tomorrow, we're doing difficult questions from November 2022, paper 1-2 and paper 1-3. That's the plan for tomorrow. We'll also decide what to do in the next classes after that. Then I'll be posting another poll today. I've actually added another option, and that will be that we do difficult questions from 2020 and 2022, so that we both things are kind of catered for, that we do some difficult questions from 2020 as well and also from 2022. But I'll basically post that in the WhatsApp group as well. Okay, so that's it for today. I'll see you again tomorrow. Yes, we will have a 15-minute break now for Maghrib, and we start mechanics around 7:25 inshallah. All right. Okay, Allah Hafiz everyone. I'm not sure. We'll have to check the thresholds. I think it's 2023 June paper, the one that came to your seniors basically, June 2023. That was quite complicated. Okay, that's it. Allah Hafiz everyone.
Allah Hafiz, sir.